Welcome for online video session. Myself Jagadish, Associate Professor, Department of Computer Science and Engineering, Canara Engineering College, Banpar. So in the last video session, we have seen the software evaluation, definition of software evaluation. Then we saw the software maintenance. Then software in the evaluation, we saw the Lehman-Bellady laws, where we have 8 laws. So during evaluation process we should follow that laws, Lehman laws. So next, what we saw the software maintenance. In the software maintenance, we saw the fault repair, environment adoption, in functionality addition, etc. Then usually the development of a software, the cost of the development of a software usually will be less compared to the maintenance of the software. So then we saw the reason for the expensive for the develop there is software evaluation, there is team stability, poor development practice, staff skills, program age structure, etc. Then next we'll see now software re-engineering. So software re-engineering or system re-engineering is one and the same, and restructuring or rewriting part of all legacy system without changing its functionality. Restructuring the system without changing its functionality is re-engineering. So that is applicably where some part, not all subsystem of larger system requires a maintenance. Re-engineering involves adding a effort to make them easier to maintain. The system may be restructured and redocumented. Whenever it is needed, the re-engineering process, the system may be restructured and redocumented. So legacy system, that is a software system, easier to maintain. So re-engineering this system improve the structure and the understandability. So re-engineering may involve the redocumenting the system, refactoring the system architecture, translating the program to a modern programming language, or something like you wrote there is software in a older version, and now due to the change in technology, it has to be upgraded to the new programming skill that we can do it in a re-engineering, that is translating the programs from the to the modern programming language and modifying and updating the structure value of the system data. So the functionality of the software is not changed, but normally it will be changed to the new architecture or new programming languages. So important benefits from re-engineering than the replacement. So instead of the replacement of a software, it is always better to re-engineer. There is a re-engineering than the replacement of a software. So in that, first one is a reduced risk, then second one is a reduced cost. So reducing risk, there is a high risk in new software development. There may be a development problem, staffing problem, and a specification problem. Something instead of developing a new software for an organization, instead of that, re-engineering the existing software only is better, because there will be a development problem or a staffing problem. Problem in the sense the person or a team member who are involved in developing a software may be shifted to some other organization, and to maintenance of the software or to evaluation of the particular software is very difficult. You have seen that maintenance cost for the evaluation process is high than developing a new software. So these are the high risk. This reduces the risk of the re-engineering process, and reduced cost. The cost of re-engineering is often significantly less than the cost of developing a new software. Obviously, instead of purchasing a new car, then altering a older, that is old car, or purchasing a second hand car will be easily cheaper than purchasing a new car. So the same way, purchasing a new software, it is always better to re-engineering the existing software to the current technology. The cost will be less. So these are the two advantages of re-engineering process. So next we'll see the re-engineering process. So in the re-engineering process, you can see here the original program, that is the program or a application or a software which is already existing, and that source code translation. So reverse engineering process and program structure improvement. In the reverse engineering process, there is program documentation, then program modulation. From the program structure improvement, there is restructuring the entire program as and when it is that is to require as per as the changes in the environment. Then after program modularization, it is re-engineered the program. Then data re-engineering from the original data and re-engineered data. So we'll see there one by one the explanation of this code, that is diagrammatical. In this source code translation, that is convert the code to the new languages. So source code translation, what we saw the previous diagram, in this diagram, that is source code translation is convert the code to the new languages. That is, using a translation tool, the program is converted from the old programming language to the modern version of the languages, or to different languages. So what we see, it converts the from the older version to the new version of the programming languages. Second one is a reverse engineering, analyzing the program to understand it. So whereas why it is re-engineering, reverse engineering, here is what happened in the earlier version. We are analyzing the specification of the customer, then implementation of the code, then testing, then release the product to the customer. Whereas here reverse engineering, from the programming we are analyzing the that is a software. So it is a reverse engineering process. So analyze the program to understanding it. The program is analyzed and the information are extracted from it. So it helps to document its organization and functionalities. Again, this process is usually completely automated. So that is what's the reverse engineering. Then third one is a program structure improvement. So program structure improvement is restructuring automatically for understandability. So to control the structure of the program is analyzed and modified to make it easier to read and understand the structure of the program, or for the better improvement of the program. So this is automatically, but some or manually it is required as the application required. So fourth one is a program modularization. It is reorganizing the program structure. Reorganizing program structure, since the architecture of the there is system has been changed, then the program structure has to be reorganized. So related part of the programs are to be grouped together, and appropriate redundancy is removed. In some cases, the stages may be involve a refactoring of the architecture. So this is a manual process. Actually, there is a program modularization is a manual process. Then data re-engineering, that is clean up and restructure the system data. So clean up and restructure the system data, that is data processed by the program, is changed to the reflected program changes. The data processed by the program is changed to reflect the program changes. So this may redefine the database schemas. So database schema or a database SQL, some of the existing database has to be converted to the new database version. So to database to the new structure. So these are the re-engineering process activities involved in the re-engineering process. So next in the re-engineering approaches, you can see here the automated source code conversion and automated restructuring with manual changes and restructuring process. It is, see, all this process, if you keep on going for automated restructuring or automated source code, the cost also will be keep on getting increases. So it's depending upon the customer whether for the entire code has to be automated or only a part of the structure has to be get automated, or if you there is a restructuring the entire architecture of the system, then the cost will be keep on getting increases in the re-engineering process. So re-engineering cost factors, the one is the quality of the software to be re-engineering. Second factor is the tool that support for re-engineering should be available. Then third one is the extended of the data conversion which is required for re-engineering, that has to be considered. Then fourth one is the availability of the expert staff for re-engineering is required for the application. So these are the re-engineering cost factors as to be seen in the software application. So preventive maintenance by that is refactoring. Preventive maintenance by refactoring, that is, one is refactoring is a process of making improvement to a program to solve down the degradation through change. And second point is you can think of refactoring as a preventive maintenance that reduces the problems of the future changes. Refactoring involves modifying a program to improve its structures, reduces its complexity, or make it easier to understand. When you refactor a program, that is nothing but restructuring of a program, you should not add a functionalities but rather than concentrate on a program improvement. So refactoring and re-engineering, it takes places after system has been maintained for some times and maintenance costs are increasing. You use a automated tools to process and re-engineering the legacy system to create a new system that is more maintainable. So re-engineering take places after a system has been maintained for some time and maintenance costs are increasing. You use a automated tools to process and re-engineering a legacy system to create a new systems that is more maintainable. So refactoring is a continuous process. There is a no endless. It's a just keep on continuous process for improvement of the system development and evaluation process. It is intended to avoid a structure and code degradation that increases the cost and difficulties of the maintaining a system. So refactoring and re-engineering, you have there is some of the examples you can see here. There is programming, there is a duplicate code, long method, switch case statements, then data clumping, speculative generatives. So we'll see one by one. There is how it says usually in the there is software program in software there is a preventive maintenance by refactoring. There is some bad smells in programming code. What are the bad smells in programming code? That is duplicating the code. The same or very similar code may be included at different places in a program. This can be removed and implemented as a single method or a function that is required. So instead of keep on you can see that instead of that is writing a plenty of code for addition of a integer or addition of the that is a float number, addition of double, something like that, it is better to write it in a single function, and the function can be called depending upon the it is integer number for the float, or you can change the method. That's enough. So that's what duplicate code. And the second one is a long method. If a method is too long, it should be redesigned as number of shorter method. So some if it is too long, it is better to redesign to shorter method. And switch case statements, this often involves a duplication where switch depends on the type of value. The switch statement may be scattered around program. In object oriented language, you can often use a polymorphism to achieve same thing. So there is a something related to the using a switch statement. So switch statement may be scattered around the program. In object oriented you can often use a polymorphism to achieve the same thing. And to there is duplication, they often involve a duplication can be avoided. Instead of writing in many code, it is uses better to use switch case statement. And the fourth point is a data clumping. Data clumps occurs when the same group of data items, that is classes, parameters or methods, reoccurs in several places in a program. This can be often replaced with an objective, that is encapsulation of all of the data. So whenever the classes, parameters, methods keep on reoccurring, it's better to have a encapsulate all of the data. That is what you see in the object oriented. And speculative generality, this occurs when developers include a generality in a program in case it is required in the future. So this can be often simply be removed in the programming code. So these are the bad smells in a programming code. We'll see in the refactoring of the that is primitive maintenance by refactoring. One is duplicate code, long method, switch case statement, the data clumping and speculative generality. So next we'll see the legacy system management. In the legacy system management is an organization that rely on the legacy system must choose a strategy for evolving this system. So scrap the system completely and modify the process so that it is no longer required. So scrap the system completely and modify the business process that is no longer required. So if you have one application where it is not at all required, so entirely you scrap the system completely, which is not at all required. Continuing maintaining the system. So you have the, say there is legacy system, so it's required maintenance, so even the cost is more for the legacy system. Transform the system by re-engineering to improve its maintainability. So if you wanted that legacy system should be used for the further there is business purposes, then it is better to re-engineer the entire legacy system for the better improvement, or its maintainability will be easy. Replace the system with a new system. Since if you do the re-engineering process, then it can, you will be getting a new system on the legacy system. So the strategy chosen should depend on the system quality and its business value. So you can see the legacy system assessment. So there is system quality as well as business analysis. So low business value as well as low quality will be having a system. There is a for system quality of a business, the business value will be at low itself. Okay, as the system quality keep on getting increases, then the business value also keeps on increases. So high business value, low quality. Since the system quality will be low, but the business value, because you are not upgrading your system, then the business value will be there is low, there is quality will be low, but business value, that is spending money to that particular system will be more. So high business value, high quality. If you spend money for the legacy system, then the business quality will be high value. So this is what the example they have given on the assessment of the legacy system. So we'll see the legacy system categorized. Before that, there are four strategies of that's what we say they seen in the this yeah four strategy. This a definite question in the examination also. What are the four strategic option for the legacy system? Scrap the system completely, leave the system unchanged and continue with regular maintenance, and re-engineering the system to improve its maintainability, replace all or part of the system with a new system. So scrap the system completely, that is when the system is not making an effective contribution to the business, it is better to scrap the entire system. There is no more use for the system, no more use for the application, or no more use for the business purposes, then it is better to scrap entire system completely. That is a better option for the legacy system, and leave the system unchanged and continue with the regular maintenances. So this option should be chosen when the system is still required, but it is fairly stable and the system user make relatively few changes request. There is continue maintaining the system. There is some system you may be required for some or other purposes, but there is no need of upgrading the system, or there is no need of investing much more for the system. Then it is better to use the same system but with a little bit of changes of the particular system, that is continuing maintaining the system. And third one is a re-engineering the system to improve its maintainability. And some systems you require it re-engineering for the better business application. So then that is at that time it is better to replace the entire system and replace all part of the system with a new system. This option should be chosen when the factors, that is such as a new hardware has been introduced, or means the old system cannot be continued in operation. At that time it is better to switch on to the new system, or to replace some of the parts of the system in the reasonable cost of the components. So this is what we saw the legacy system example. And the legacy system categorized that is low quality, low business value, low quality, high business value, high quality, low business value, high quality, and high business value. So you have seen the diagram, that is they are structured into there is a cluster. They have a four cluster of the system. So low quality and low business value, that is system should be scrapped. If the system is having a low quality and low business, then that system should be scrapped easily, because there is a, see this is what they have been mapped, that is put into graph, that is 1 2 3 4 5 and 6 7 8 9 10. So then they are clustered into that particular there is categories. Then that in that low business value, low quality, and that is better to keep the system in operation, will be expensive. That is better to rate of the return of the business value will be fairly small. At that time it is better to scrap the entire system. You are getting a very low value, but to maintaining maintenance of the entire system is cost is high. So better to scrap the entire system which is having a low business value and low quality. So second point is low quality, high business value. So these systems are making an important business contribution, so they cannot be scrapped. So you are having a low business value but high quality, that is sorry, low quality and low quality with high business value. That should be changed. Low quality, high business value. This system should be has to be, cannot be scrapped completely, cannot be scrapped. However, the low quality means that it is expensive to maintain them. The low quality means that is expensive to maintain them. This system should be re-engineered to improve their quality. This may be replaced suitable for the system for the business purposes. And high quality low business value, high quality low business value. So in this high quality low business value, there is these are the system that is replaced with the there is costs and scrap completely or maintenance. These are the system that do not contribute much to the business, but which may be not be very expensive to maintain. And at that time there is no use of having that type of system. It's not at all worth replacing this entire system. So normally system maintenance may be continued if expensive changes are not required and the system hardware remains in use. So if the expensive changes becomes necessary, then the software should be scrapped. The expensive changes becomes necessary, the software should be scrapped. High quality, high business value. So these systems have to be kept in operation. However, the high quality means that you do not have to invest in transformation or a system replacement. So there is no need of transformation or replacement of the system. Normally system maintenance should be continued throughout because they are having a high business value. So these are the four that is clusters of the system of the that is system assessment: low quality, low business value; low quality, high business value; high quality, low business value; and high quality, high business value, which has to be kept for continuous business purposes, or which has not to be kept is depending upon these four clusters. So business value assessment, in the business value assessment, there is four basic issues has to be considered. There is uh, one is the system end users. There is nothing but the use of the system, and the second one is a business customer or a business process. Third one is there is a line manager, and fourth one is a IT manager, and fifth one is a senior manager. The assessment should take place. The take different view into account. So interview different stakeholders and collect the results. So business issues, there is a uh, issues in business value assessment is one is the use of the system, second one is a business process that are supported, and system dependability and system outputs. So use of the system, if the systems are only used occasionally or by a small number of people, then that may be have a low business value. So you have purchased a car, and where you not riding or car regularly, at that time even the what you spend with for the petrol is very less. So then there is no use of having the car for where it is not able to serve the purposes. So that type of system that is having a low business value. So if the systems are used occasionally or by small number of people, then they have a low business value. Second one is a business process that are supported. That is when a system is introduced, that is a business process are designed to exploit the system capabilities. If the system is inflexible, changing this business process may be impossible. The system may have a low business value if it is forced to use inefficient business process. uh, Third one is a system dependability. System dependent, if a system is not dependable and the problems directly affected the business customer, the system has a low business value. That is, if the system is not dependable and the problem directly affect the business customer, the system has having a low business value. So if the system is not dependable, that is something like it's a technical problem but also business problem also, then it will be affected directly to the business customer. Means that the people in the businesses are diverted from other tasks to solve this problem. The system has a low business value. So people may try to solve this technical problem we are in the business. At that time the automatically the business value gets low, go down. Then the fourth one is the system output. There is if the business depends on the system output, then the system has a high business value. So the key issues here is to importance of the system output to the successful functioning of the business. If the business depends on this output, then the system has a high business value. Conversely, this output can be easily generated in some other way, or if the system produces a output that are rarely used, then the business value may go low. So these are the four strategies or four basic issues that have to be seen in the business assessment value. System quality assessment. In the system quality assessment, there is business process assessment, environment assessment, and third one is a application assessment. So in the business process assessment, how well does the business process support the current goals of the businesses? In the environment assessment, how effectively or effective is the system environment and how expensive is it to maintain? Application assessment, what is the quality of the application software system? So these are the four or three system quality assessment. So business process assessment, yeah, in the business process assessment, use a viewpoint oriented approach and seek answers from the system stakeholders. So what are the, if there is a defined process model and it is followed, do different parts of the organization use a different process for the same function? How has the process been adopted? What are the relationship with other business process? And this necessary, is the process effectively supported by the legacy application software? So these are the business process, that's much not important. Yeah, we go for the factors used in the environment assessment. In that factors that is a definite question in the examination. What are the factors used in the environment assessment? In that we have a that is seven factors. One is supplier stability, second one is a failure rate, third one is age, fourth one is performance, and fifth one is support requirements, fifth one is maintenance cost, and sixth one is, sorry, seventh one is interoperability. So we'll see one by one. In the supplier stability, is the supplier still in existence? Is the supplier financially stable and likely to continue its existence? If the supplier is no longer in business, does someone else maintain the system? So supplier stability. So always, whenever when you start running a businesses, whenever you want to purchase any of the there is raw materials from the market, then the supplier has to, you have to see, these are the question to be put to run your business successfully without go down. So whatever that, is the supplier still in existence, will be there in to how many years? If the supplier is financially stable, even if you not give him money, that is to the that is supplier in regular that is a regular basis, whether it will be stable and the stable, and it will be continue supply the raw materials. These are the question has to be checked in the environment assessment factors. And for third or second one is a failure rate. Does the hardware have a high rate of reported failure? Does the support software crashes and force the system restarts? Failure rate in the sense you have purchase the software and you may purchase the hardware which is now having a that is in the, that is you purchase the hardware of there is low quality of hardware where your software won't support that hardware, that is at that time failure rate will be high. At the time when the failure rate is high, the system get crashes, then you may lose a business, and automatically there is your business get down. Then at the one fine day you have to shut down your company. So all those things you have to taken care while assessing the there is when you start businesses. Age, how old is the hardware and software? The older the hardware and older the hardware and support software, the more obsolete it will be. It may still function correctly, but there could be a significant economic and business benefits to moving to a more modern system. So you are running a legacy system. There is then you have to check out how old the hardware and software it is. If it is older the hardware, then the whether the software will be support or not, you have to check out. If it is there is then automatically the if it is not supported, the automatically the business goes down, and benefits to moving to more modern system. Performance, is the performance of the system is adequate? Do performance problems have significantly effect on the system users? And fifth one is a support requirement. What local support is required by the hardware and software? If there are high costs associated with this support, it may worth considering the system replacement. So hardware and software, if you see that legacy system, if it is high, then better to go for the replacement of the new system itself. Maintenance cost, what are the cost of the hardware maintenance and support software license? So you have a hardware and you purchase a software, then you have to purchase a supported license software itself. So older the hardware may have a higher maintenance cost than the modern system. Support software may have a high annual license cost. So usually when you purchase any of the antivirus, you have to go for switch on to the renewable of the antivirus regular interval of a years. So the cost of the antivirus, there is a software is high. Better most of the there is organization will switch on to the Linux, where antivirus is not at all required for that operating system. So the maintenance cost also has to be taken care in the legacy system. Interoperability, are there problems interfacing the system to other systems? Can compiler, for example, be used with the current version of the operating system? Is hardware emulation required? So these are the factors used in the environment assessment in the legacy system. So Seven factors has to be checked on the supplier stability, failure rate, age, performance, support requirements, maintenance cost, interoperability. So factors used in the application assessment. So what are the factors that is used in the application assessment? That is one is uh, understandability. Second one is a documentation. The third one is a data. Fourth one is performance, and fifth one is programming language. Fourth one is programming language. Sorry, fifth one. Sixth one is configuration management, and sixth one is a test data and personal skills. So we'll see one by one of the further factors affecting the application assessment. And one first one is a programming language or modern compilers available for the programming language used to develop the system. Modern compilers are available for the programming language that is used to develop the system. Is the programming language is still used for a new system development? So you develop a that is one that is programming language, then whether the compiler is there for to compile the program has to be checked. Our programming language is still used for the new system development, has to be checked. The program there is what is developed in the legacy system, is that still able to develop a new system, has to be checked. In configuration management, are all version of all parts of the system managed by the configuration management system? Is there an explicit description of the version of components that are used in the current system? Has to be checked. Test data, does test data for the system exist? If it is, then you have to check the test data. Is there a record for a regression test carried out when new features have been added to the system? If you had any functionalities to the existing system, whether it get a correct output or not has to be tested. Personal skills, are there people available who have skills to maintain the application? So since it's a legacy system, whether we have a skilled person is still available in the organization to maintain the system, or there people available who have experience with the system, has to be checked. And yes, understandability, how difficult is it to understand the source code of the current system? And documentation, what system documentation is available, is the documentation is able to have a complete consistency and current data is then an explicit data model for the system. To what extent data is duplicate across the files has to be checked. Performance, is the performance of the application is advocated, do the performance problems and affect the other system users? So these are the application assessment. And second one is there is first one is understandability, documentation, data, performances. And there is fifth one is programming language, configuration management, test data and personal skills. So these are the 8 application assessment factors of the legacy system. And system measurement, the system measurements, you may collect a data to make an assessment of the quality of the application. There is one is the number of system, there is number of system change requests. Second one is a number of user interfaces. Then third one is a volume of data used by the system. And the number of the system change requests. System changes usually corrupt the system structure and make changes more difficult. So the higher this there is value, the lower the quality of the system. So your system change usually corrupt the system structure and make further changes more difficult. So there is one number of system change requests. The number of the system change requests has to be identified before doing any changes to the existing system. So number of the user interfaces, this is an important factor in a forms based systems where each form can be considered as a separate user interfaces. The more interfaces, the more likely that there will be a inconsistency and redundancies in the interfaces. And the third one is the volume of the data used by the system. The higher the volume of the data, that is number of files, size of database, etc., the more likely that it is that there will be a data inconsistency and reduces the system quality. if you have a high data, then it automatically reduces the that is speed of the system. You can see in your system in mobile also, if there is a no space, or if the space is filled, or even the system also, then automatically if there is no space in the C drive, then automatically your system gets slowed down. So these are the system measurements have been taken care. That is quality of the assessment has been taken. There is one is number of system change requests, number of user interfaces, volume of data used by the system. And yeah, by this I will wind up the fourth module of system. There is a second chapter, system evaluation. So first one is software testing, and second one is a system evaluation. So if you have any doubt in this regard, please let me know in the online session, and suggest please view the videos. If you once, if you understood once, okay, otherwise you will view the video once again. Yes, thank you all.